Let's get this party started. Okay, so back in about 4 years after I graduated high school. So a little over 4 years after I graduated high school back in the day. We'll get this kicking.
Well, good morning. I hope you are doing good. Today we are going to start with statistics. We're going to start pretty much with, like I said, just some of the.
Gonna let this power through because we're gonna be moving real fast here in a minute. I'm talking real fast. Now, generally, I know any one page is every day. Could be one board, could be both boards. I could fast forward this to the end and just write down the notes. That'd be easy. Great. That's one. But obviously, you're going to miss some of the good bits in between here of what he's trying to tell you about, or the example that comes up, or for the homework I want to design. This guy's like, oh, I'm going to have to take notes right off the front. He's out the door. He doesn't understand how easy this is, actually. Well, we're going to get into it. We're going to change some of these bits and bytes around here in a minute. 1-1, key, word, prime, prime. They are both the same thing in superposition of one another. Data, 1 and 0. Data compression, where we heard it. Where do I want to use it? Why does it come up right hand rule in data compression? Data compression. No! Bad data. Bad GPT-3.
When we talk about data in this class, really all we're talking about is observations. The information that we're collecting, whether
Take a ride with me, shall we? This black hole of black holes and cosmic web radiation, they're not telling you anything that you're graphing. Like I said, why did I sneak you out data compression early? When your D&D board, as it were. Oh, why? Why?
It kind of sounds like that. I'm a little afraid.
Okay.
So any observations that have been collected, that's what we're calling data.
Are you struggling in your calculus class?
Well, good morning.
Down.
I hope you are doing good.
Damn it, GPT-3, if I gotta come in there.
Today we are going to start with statistics. We're going to start. So in this video, we're going to talk a bit more, a lot more. Like I said, just some of the vocabulary, inverse functions that we just learned.
Bad monkey.
Sine inverse, cosine inverse, tangent inverse, is framed down a little bit about cosecant,
Close
secant,
enough.
and cotangent inverse.
This ball, very important. Very important. Let's talk about what key words are. Okay? Key words and data. Okay? Now, keywords it's gonna go with this curveball coming at you fast in a hurry. Inside here, Solomon Circle, I want you to put it in. I want you to put the demon in the circle. Okay? Well, this is going to be a ball. I'm going to tilt you on an angling value for one thing this ball will do. Why? Because data. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Okay? So inside of there, what's the orientation? Well, here we're going 1, 0. Maybe that's hot or cold. Now, mathematically, he might say something to me here about something I'm not getting into. But either way, hydrogen, helium, periodic table, physics and plasticity, bing bang, it is bits and bytes and or if and when, maybe. But you're using this hard line for that, not the other one. My point, magnetism's going to do that. Gravity's going to do that. Compositions and stuff like that. So any observed 0, 1. What do you mean what's observed? I'm about to explain to you what I just saw. And observed an angle. I saw that there was a shift or a... When that thing happens, there's a cosine commonly that happens with it. Either the result it does, or some operator that commonly Euler numbers this on that. You know. Okay, so back to data compression. Why is it important to start zeros and ones here? Because then I'm going to start changing 0, 1 to population 1, 0. I'm starting with what the number is to figure out what 0 is. So that's its own form of data. 1-1. Stats, statistics. What are you going with here? Where are we going here? Statistics, data, statistics, data. Any observed thing that you did. So they're kind of the same thing. And I don't want to orientation of 0, 1, 1, 0. Or if I wanted to go, well, 0, 1, 1, excuse me, 0, 0, 1, 1. So it's clean. Now this won't do this. This will want to make this 3.145 pi over 2 on charge. So the secant on that, am I dealing with negative points of information into the positive, or am I dealing with something that I can't go back to the original point to determine what it was? The thing is already in motion, and we are here with it. So those will give me bits and bytes, and those bits and bytes fit squared, compressed. They want to be in superposition in this polarized wave function, right? And it's in pipes, it's got some spin while you're shooting it down the barrel. Here's a bunny. It's or maybe it's on the side, or whatever orientation you got to have that to. So bits and bytes are important, because one, computer science is a real quick one to get into it, but so is chemistry, and it's a missed one in here. Why that kid walked out of the classroom, missed it on the notes. This you figure this out, it's like, hey, well, you figure out where the gaps are. I would kill you on the notes. It's like you're supposed to have a finished book when this is done, page. Now, I could go through that entire 9 years ago. So starting now, if I wanted to go through this, click, bang, I'm at the back end of it. That's the sign of this process. Now, what I choose to put in there, data, statistics, sign, being data, the coefficient of that data has a definition, right? And that most common definition fits in the pipes. And there's the ball. That's the ball. Now, all that stuff, they're negative E's. They're in E2, E0, E1. It's moving, Mario moving from the finish line, but it's flat land, right? Mario's not going to go divergent from the path to find Princess Peach on the sign. He's going to go any cosh variable to maybe there's maybe there's some tube levels, maybe there's a magic fluid out there, but we're just going to assume regular gravity on you running around out there, Vitruvian man or woman. That orientation on that for any tangents that says within the entropy, size, shape, girth, trajectory, has a population that has an also set number inside of there. Now, given calculus 1 for fish population, it's going to start with what I caught, Well, what if I only had 1 day as control on that index? Some kind of system that said, well, the populations, I have more days, I have more statistics at that level, bits and bytes. Zeros and ones don't necessarily correlate this perfect pattern of results, nor does it say, when I make tread cuts, so here I am, I clock in the morning, that's a sign, I know I got to get at least a pallet a day. When that happens consistently enough, you know that I could probably get it in on a line that's about 3/4 of the day I should be able to get a full pallet done. Now, if I overset that to go, I should be able to get a pallet and a quarter done by the end of the day, you're going to have problems. Yes, you can get that done. That might be a correct answer, but I know that this one is completely banded. I know that the floor setup, it's in for a good setup in the morning. I've made my over. I've turned on this system, and then that tangent becomes its own XY line, its own being a one-dimensional, two-dimensional coordinate that starts to 3.145, 1, 2, 3, into 1, 1, 2, 3, 4, 1, 2, 3, 4, 5, starts to ramp this up in the first set of the Hydron Collider. I made a run. I clocked in, right? That's 3 dimensions. X, Y, Z, I'm standing in the marshmallow. Right there's that demon. Clocking in the morning. Some of them do great. Some of them don't do so great. Some of them... Inside of here, the data compression still meant to frames, right? Stone mill. Clocking in the morning. Now, everybody clocks in the morning, even if it show up in this class. It might be a tangent, but click this down. It might be a population note that you say, hey, that's a data, that's a box. I want to graph that. I want that marshmallow. And so you keep coming back here. So you don't, I mean, yeah, if I can graph and be like, all right, slave crew guy, let's take Solomon's book here. Sure. You know, and go to him about Newton and FMA and how things roll, friction, work, standards inside here. Yeah, you know what? Maybe you go make bricks for the Pyramid of God over here and in the Mason Lodge or the mathematical house. Useful and interesting for gravity calc on what it does. Now, hey, you know it's money. Eh? I'm not. If I was in the Carney stage and it was the Masons games, I am ready. Plus, this comes in handy. Like he's gonna push this writing lecture notes, this dead giveaway on an observation down the pipes of how that'll spin momentum. You know, so you're getting a lot of observation IH, and that's usually where I slide that in here. IH, keyword. The Latin has more to do with the math than it does some demonic kid coming at you with some symbols back in the day because Solomon's Temple, and then you go work in the stonemasonry. It's like, I have yet to actually see a physical dragon come out and give me a kiss in any of this, but I'll tell you what, the stone mill, you go picking up the stone mill, you go dusting off everything underneath, you find dragons. All kinds of things about running hard like that, and the top end of gravity numbers, can't do shit about it.
Let's move on. So we're taking a look at tangent.
Just looking across the field. That hurricane problem, huh?
Remember what these things do. Tangent means an angle.
We don't get those hurricane storms on the force that brings the demon, Solomon. What do? Throw it on the coast. Throw it in.
Regular trig functions give you in angles, give you out.
Oh, you wanted to go, yeah, Green Lantern Corps, Purple Lantern Corps. I'll line you up. I get you. Athena, you want to run? Power Rangers, I don't care. If you're willing to play it out here. Now, are they real things? Are you going to do storyboard? That's great. You're going to have to keep it some level of reality and gravity.
For some of you, it's going to be really easy to look at this population. We're talking about, I understand whole group samples of a subset, and a census would be considered a circle.
Like I said, what you're going to put in here is vastly different in looks. You're going to be graphing a bunch of stuff. There's going to be a lot of the same graphs. He's just showing you the key base. Data, statistics, sine, cosine, population, sample. Can't quite read that. But at any rate, alright, so data, statistics, population, sample, or however you want to break that down. You want to go data, statistics, bing, bang, boom. Well, data, statistics, M1 and M2. I got money on something. I got time on something. Well, the statistics on the money in the stone mill says I have an abundance or I have an abundance of time. Both go to the cleanup first. Run off what the cleanup is, make sure we're servicing off that before, if time. Money may not be a relative factor to that unless it's, you guys want some OT cleaning the shop. But M1 and M2, MNN go to some value inside of it. Women's hard to put to the table on stone mill just like it is man. I don't own a lot of those things and I can't necessarily guarantee you're going to go those levels in the stone mill unless you go calculus like this at the board of graphing guys and their statistics every day, making rounds, getting their cut coefficients for them so that they know what their numbers are. You're not doing any shiesty shit with the boss. You're just doing it for gravity. Why? Because what's important on that is, boss, that number's for you later on. We have simple rules about promotions and raises. The questions come up in the pipes, like actions at spooky distances, because it's just the day's timeline. That we could ramp up by stories and Bernoullis and changing out the values and names on some of these things pretty easily. But, AUAX, man. AV, or VAY, and, you know, you want to do that at 0110, the orientation of data and statistics change. Somebody gave me a statistics, ones and zeros in the program. Somebody gave me the data, but I got to put in the statistics in the computer is what it is. So it's those numbers and these clickety ticks and tangent, sine, and something else. But meanwhile, you never left.
that Joe Schmo, Republican